দরজাটা তাহলে দিয়ে দে, দরজাটা বন্ধ করো। হ্যাঁ, okay, so today we are going to discuss simple harmonic motion of class 11 part. As you know, very important topic because at least 4 questions are asked every year in Neet from this topic. Okay, at least 4 questions. Sometimes 5 questions are also asked from this topic, but you will get at least 4 topics. Okay. To study this chapter, we will first take an introduction on what is simple harmonic motion. But before that, আমরা আরো 2 types of motion discuss করব. After that we can study this simple harmonic motion. Okay. First, let's learn what is oscillation first of all, or vibration. Oscillation, vibration, oscillatory motion or vibratory motion, they are basically the same thing. What is this? Oscillation or vibration is to and fro motion. Oscillation or vibration means to and fro motion. To and fro motion. To and fro means the body will move between 2 extremities, between 2 fixed points, which points are called extremities. Like, consider the motion of a pendulum. If you take a pendulum little bit away from the mean position, this point is called the mean position or marked x equal to 0 position, little bit away, and then leave it for oscillation. The pendulum will oscillate between 2 fixed points on left and right, say A and B. Here the points A and B are called the extremities. You can also take another example of a spring. Suppose the spring is connected to a mass. If you move the mass little bit away from its position and then leave it, you will see the mass being oscillating between 2 fixed points, between 2 ends. These are those 2 fixed points, one A and B, which are called extremities. This type of motion is called oscillation or vibration, when the body moves between 2 fixed points, the 2 fixed points being called its extremities. The other type of motion that you need to know is a periodic motion. What is a periodic motion? A periodic motion is the one in which the particle repeats its velocity, acceleration, position, etc. Repeats the values of acceleration, position, velocity, etc. after a certain time interval called its period. Like, consider motion of Earth around the Sun. When Earth travels around the Sun, what happens? Suppose this is the initial position of Earth, and that is Sun. After every 365 days, the Earth comes back to the same position. So we say time period of the motion of Earth around the Sun is 365 days. Consider the motion of a minute hand of a clock. After every 60 minutes, the minute hand comes back to the same position. Consider the hour hand. After every 12 hours, it comes back at the same position. Consider a second hand. After every 60 seconds, it comes back at the same position. So all these motions are periodic motions. Even vibration or oscillations can be periodic. Like consider a pendulum. In the previous example, generally the pendulums that we use, which are simple pendulum, has a time period of 2 seconds. That means the pendulum takes 1 second to go from one extremity to the other, 1 second, and then take another further 1 second to come back from the right to left. So total 2 seconds are taken by the pendulum in one oscillation. So this motion is also periodic. Oscillation and also periodic. So any motion that has a fixed time period is called a periodic motion. We will take a very important note on periodic function here. If the position or velocity or acceleration of a particle is function of time such that the function itself is periodic function, then we call the motion to be periodic. I'll repeat. If velocity, acceleration or position of a particle is such that it is a function of time, I mean the velocity might be a function of time, acceleration might be a function of time, position might be a function of time, such that the function itself is periodic. That means the function repeats its value after a certain period. Then the particle will be called, the motion of the particle will be called periodic. So what is a periodic function? Then we have to learn that. You have learned probably about the function in mathematics. It comes from set theory or mapping. What is a function? Like consider this example. Example 1. Say x equal to 2t minus 3t square. So here you see the value of x depends upon t. X is position, t being time. So here we say x is a function of time. X equals to ft. The symbol means x is a function of time. That value of x depends on t. Like you put t equal to 0, you will get x equal to 0. You put t equal to 1, you will have x equal to 2 into 1 minus 3 into 1 square. That is 2 minus 3, that is minus 1, and so on, etc. etc. You put a particular value on the right hand side for the t, the argument of the function, the variable, you get a value of x. So here we say x is a function of t. That means x depends on t. But see, in this case, তুমি টির যত ভ্যালুজই বসিয়ে যাও না কেন, x এর ভ্যালু আর তুমি ব্যাক করে পাবে না, মানে this is not a periodic function. You will not get many values of t for which the value of x will be repeated. For each t, x will take different values. So this is not a periodic function. But consider this example. X equals to sin t. Let's find out some values for x and t. I will put value of t, I'll put value of x. When t equal to 0, you will see x is 0. When t takes the value pi by 2, x takes the value sin pi by 2 90 degree, that is 1. T takes the value pi, x is sin pi, has value 0. t takes the value 3 pi by 2, sine has value -1, t takes the value pi, x takes the value again 0. In general, you put t equal to pi or 2 pi or 3 pi, etc, etc, etc. Oops, sorry, it would be 2 pi, very sorry. So you have to put the values like this, equal to 2 pi, 4 pi, 6 pi, etc, etc, etc. Every time you will get the value of 0. Or you can also say, sir, I don't have to do that, I can do this. Just take t to be 2n pi in general, n being any number, 0, 1, 2, etc, etc, etc. Put n equal to 0, you will have 0. Put n equal to 1, you will have 2 pi. Put n equal to 2, you will have 4 pi. Put n equal to 3, you will have 6 pi. For all these values, actually, x will take the value of 0. So we see after every interval of 2 pi, the function is repeating its value. X is coming out to be 0 after every 2 pi radian of interval. So we say time period of sin t function is 2 pi. Similarly, you can take another function and can try yourself. Like, I'll give you one more example. Say x equal to cos t. Let's put some values for t and x. You put t equal to 0, cos 0 is 1, pi by 2, 0, pi -1, 3 pi by 2, 0, 2 pi, 1. So look at the repetition. The value of x is repeated after an interval of 2 pi. You go from 0 to 2 pi, value of x becomes 1, 0, -1, 0 and again 1. So we say time period of cosine function is also 1. Time period of cos t equal to, 2 pi, not 1. Because after every 2 pi radian of interval, x equal to cos t, the function is taking back its value. So these types of functions in general are called periodic functions. Definition of a periodic function, you can just note it. You will not have to make much use of this. Just write down the definition. If fx is a function or ft is a function such that value of t plus capital T has same value as ft, then it will be called periodic, and t will be called the time period. Now we have seen sin t plus 2 pi has same value as sin t, so we say 2 pi is the time period for sine function. Cos t plus 2 pi will have same value of cos t, so we will say 2 pi is the time period of cosine function, and etc. For our study, we will just keep it limited to sine and cosine functions. There are other periodic functions not required for us. So end of the story. কি জানলাম? Sine functions and cosine functions are periodic. They repeat their value after a certain time interval. What about the graphical representation of sin t and cos t? Sin t function will take the graph like this. This is the value of t, here is the value of sin t. 0, 2 pi, etc. Pi, 3 pi, 4 pi, etc. And the cosine functions, they look like this, because when t equal to 0, the cosine function took the value 1. So graph of t versus cos t looks like this. It starts from the maximum. This is 2 pi, after which it repeats the value. This is pi. This is again 2 pi, 4 pi. This is 3 pi, etc. Okay. Now we will take a note. One of the most important notes of this topic. Let a particle has its displacement x given by the equation a sin bt, where a and b are constants. At, you can see, t equals to 2 pi by b, x will take the value a sin b into 2 pi by b. That is a sin 2 pi. From previous discussion we know that sin 2 pi takes the value of 0 here. Sin of 2 pi will assume the value 0. So this is 0. Also at t equal to 0, x takes the value 0. So after an interval of 2 pi by b, the function repeats its value. Here the function means the displacement of the particle x. X is the displacement of particle, which means after 2 pi by b interval of time, the particle comes back to the original position from where it started. At t equal to 0, x equal to 0 means at t equal to 0, the particle is at mean position. That is the mean position. X equals to 0 means particle lies at mean position. At t equals to 2 pi by b, the position is again 0. That means the particle is again at mean position. So after every 2 pi by b of time interval, the particle comes back to mean position. Meanwhile, it goes away from mean position somewhere, I don't know. But after the interval of 2 pi by b, it again comes back to the mean position. So time period of its motion is now 2 pi by b. So time period, capital T, of its motion is 2 pi by b. Now, let's find the velocity of the particle, v. Velocity will be given by dx upon dt. Take the derivative of a sin bt first. Sin bt's derivative would be cos bt, and then bt's derivative would be b. So b cos bt, applying chain rule. So it's ab cos bt. You can see it's again a periodic function. So time period of the velocity it's also the same. Sine and cosine functions both are periodic. So after 2 pi by b interval of time, we see the particle comes back to the mean position with the same velocity with which it started, because the velocity will also repeat its value by the property of periodic function. After the period, the function repeats its value. X function is sine function, like here. So after 2 pi by b time interval, particle comes back to original position. V function is also periodic function, ab cos bt. So at t equal to 0, whatever its velocity, after a time interval of 2 pi by b, the velocity would be the same. The velocity also repeats itself. Also, let's find the acceleration of the particle A. That would be dv by dt, which is ab times cos bt will be differentiated to minus sin bt, cos bt derivative minus sin bt, and bt derivative already b. So it will be minus, I already put the minus sign before. It's like this, minus b sin bt. Derivative of cos bt is this, b sin bt with the negative sign. So it's minus ab square sin bt. See, another sinusoidal function with the same time period. Time period of acceleration function, that's also the same, 2 pi by b. Now let's reminisce what we stated at the first. I told you, if the particle is in periodic motion, its displacement, velocity, acceleration, all might be periodic. Here we see the same thing. The particle that moves with equation x equal to a sin bt, whose displacement is governed by the equation x equals to a sin bt, has periodic displacement, periodic velocity, and periodic acceleration. Values of acceleration, velocity, and displacement all are periodic, repeating after the same amount of time, 2 pi by b. Clear? Now we are equipped to learn what is simple harmonic motion instead. Simple harmonic motion. Displacement equation. We will start from the displacement equation again. And velocity and acceleration. I'm going to repeat just what we have started. We have seen if displacement of a particle x takes the form x equals to a sin bt, its velocity comes out to be ab cos bt, and subsequently the acceleration comes out to be minus, it's already written in the board, look at the top right corner, minus ab square sin bt. Here there are two a's. Let's not confuse them. So I will put a vector notation to denote that it is the acceleration and not the constant a. You can do the same in this question as in this part as well. You can put a vector notation over a. So acceleration can be written as minus b square a sin bt minus b square a sin bt, but a sin bt is the displacement of the particle x. Now put vector notation everywhere. So you can write acceleration vector equals to minus b square times displacement vector. Since a sin bt is x, as you can see. So if displacement of a particle assumes the form x equals to a sin bt, we see the acceleration is related to the displacement by this equation, a equal to minus b square x. The motion where the acceleration and displacement are related like this, acceleration equal to minus times a constant square times x, acceleration will be equal to negative a constant square times x. This type of relation between acceleration and displacement is called simple harmonic motion. I mean, simple harmonic motion is that motion where acceleration and displacement bears this relation. Or more simply, you can say, since b is constant, acceleration vector is proportional to x but in negative direction, in opposite direction. Acceleration vector is proportional to negative of displacement. Basically, this is the defining condition or definition for a motion to be simple harmonic. So we say a motion is simple harmonic when acceleration is proportional to minus x. That's the end of the story, for the definition at least. So now let's take the definition. A motion is simple harmonic, or SHM will be called SHM, if acceleration of the particle will be proportional to minus of the displacement. That's it. So every motion where we will find acceleration is proportional to minus x will be called a SHM, simple harmonic motion. Like the motion we just discussed here. We started displacement of a particle a sin bt. We see that here it bears the relation a proportional to minus x. So if displacement of a particle is given by x equal to a sin bt, it's SHM. Which displacement equation defines SHM or denotes SHM? Which displacement equations will signify simple harmonic motion? Answer is any sine or cosine function. Containing time variable is simple harmonic motion. Any sine or cosine function containing time variable t, that contains t in its argument, is an SHM. Example 1. This was already discussed. So we will just take the form. We will just write down the form. X equals to a sin bt. This type of form, obviously this denotes SHM. Let's take example 2 and let's prove ourselves that if we take the function to be x equals to a cos bt, this will also signify an SHM. Let's prove it. Suppose x is given a cos bt. What will be the velocity of the particle? Dx upon dt, the derivative. There would be a times minus b sin bt. We already did it. So I'm just doing it in a running hand. Minus a b sin bt. So acceleration vector dv dt, derivative of velocity, minus ab times b cos bt minus ab square cos bt. If we rearrange the terms, it will give us minus b square times a cos bt. See, acceleration is proportional to, from there you can write acceleration is equal to minus b square x again. Then next line you can write acceleration proportional to negative of x. If you wish, you can put vector sign on x, v and a everywhere. So see, here we also see that if displacement of a particle assumes the form a cos bt instead of sine, the relation a proportional to minus x is also valid for this equation. So it's an SHM. The motion is simple harmonic. Then let's take one more example. Suppose displacement of a particle x is given by this equation: a sin bt plus a1 sin bt plus a2 cos bt. Will this represent an SHM? Will this be simple harmonic motion? Let's see. X equals to a1 sin bt plus a2 cos bt. Let's assume that a1 equals to a sin theta or a cos theta if you want. You may choose by yourself. Say a1 equals to a cos theta and a2 equals to a sin theta, where a is any real number, theta is any angle between 0 to 90 degrees, an acute angle. By trigonometry this is possible. You can take any real number in the world and convert it to this form, a cos theta, and you can take another number to be a sin theta. Then the equation reduces to a cos theta sin bt plus a sin theta cos bt. You take a common and rearrange the terms: sin bt cos theta plus cos bt sin theta. Sin a cos b plus cos a sin b formula, it's sin a plus b. That's the displacement of the particle. So let's find the velocity. It will be dx dt, the same. That would be a b cos bt plus theta, and acceleration dv dt. Take furthermore derivative, it will be same as minus ab square sin bt plus theta. You can check it by yourself, we already did this. After rearranging the terms on the right hand side, you can write it like minus b square into a sin bt plus theta. So acceleration equal to minus b square x again. So acceleration is proportional to minus x, which means this denotes an SHM. So not only a sine or cosine function, even if a sum of sine and cosine can represent simple harmonic motion, if properly given. Properly means, look at the arguments of sine and cos here. Both are bt. If these arguments would be different, then this could not represent an SHM. We will discuss that later, not as for now. The arguments here are same. Sine and cos, both have the argument bt. Argument means ওই sine cosine part এর পরে যে ফাংশনটা পাবে, it's called argument. In terms of physics, is called the phase. bt is the phase of the sine function, whereas bt is also the phase of the cosine function. Here two waves, two SHMs are added with same phase. If the phase would be different, it could not be an SHM. We will discuss that later. Or it might be an SHM depending upon other conditions. We will take one more example and then we will move on to learning something new. Let's take example 4. Consider a spring mass system like this. A spring is connected to mass. Mass is m, spring has force constant k. If you displace the spring, the block, little bit towards the right, say by amount x, and take it to a new position, we already learned the spring will generate a restoring force. The restoring force will be in a direction opposite to the displacement. Here displacement has happened towards right, the restoring force will be produced in a reverse direction. The amount of restoring force by Hooke's law, it's kx minus kx, minus sign because x and f has opposite directions. The restoring force would be minus kx. K means spring constant or force constant of the spring. So acceleration of the spring would be by Newton's second law, restoring force by mass, that is minus k by m times displacement. Look, k is spring constant, it's a constant. The mass, it's also a constant, which means the total thing happening here, the k by m is also a constant. So for the next line you can write acceleration is proportional to negative of displacement. If you discard a constant sign from an equation, you can convert the equation sign into variation. K by m constant, we have discarded the constant part, so we have converted the equation sign into the proportionality sign or variation sign. Now this was our definition for SHM. So motion of the block, if you connect a block to a spring, just pull it slightly and release, the block will oscillate and the motion will be simple harmonic because acceleration is proportional to minus x. There are many examples that can be cited which are simply the simple harmonic motion. We will study many more motions later. এরকম ধরনের আরো অনেক মোশন আমরা পরে পড়ব। আপাতত আমরা এই চারটে এক্সাম্পল রাখলাম। তাহলে কি দেখলাম, x equal to a sin something or cosine or sin plus cosine এরকম ধরনের হলেও সেগুলো সিম্পল হারমোনিক হচ্ছে। আর স্প্রিং মাস সিস্টেমের ক্ষেত্রে স্প্রিং মাসের যে অসিলেশন গুলো সেগুলো সিম্পল হারমোনিক নেচারের। Now we are going to study waveform of simple harmonic motion. ওয়েভফর্মটা অলরেডি আমরা স্টাডি করেছি, ওইটা নিয়ে আমরা আরো দু একটা কথা বলবো। By meaning or by writing waveform of simple harmonic motion, we basically want to describe the displacement versus t graph. That is our purpose actually. That is, the waveform of simple harmonic motion is depicted by plotting the displacement versus time. So let's take the simplest form, x equals to a sin omega t, a sin bt. We just learned where a and b are constants. If you plot these on a graph like that, we already learned the graph would be a sinusoidal graph. Just draw it by yourself. There will be repeating waves like this and so on. Carefully look at two special points. I mean the zenith and the nadirs, the top and the bottoms, the hills and the crests of the graphs. Along the time axis, the position initially is x equals to 0. So I'm showing it by a yellow colored arrow. The length of the arrow is the maximum displacement of the particle. See, the particle does not go beyond that distance starting from the origin. Same thing happens on the other side, which means the mean position of the particle is the white line. যখন পার্টিকেলটা মোশনে আছে তখন আপওয়ার্ড এন্ড ডাউনওয়ার্ড ডিরেকশনে বা লেফট রাইট যেভাবে খুশি পাবো, the particle is not going beyond a certain distance. এটা ম্যাক্সিমাম ডিসটেন্স যাচ্ছে ওদিকে আবার এদিকে, বোথ সাইড যে কোনো দিকেই মিন পজিশন দ্যাট ইজ দ্য হোয়াইট লাইন, ওখান থেকে একটা ম্যাক্সিমাম ডিসপ্লেসমেন্ট আছে পার্টিকেল, তার বেশি ডিসপ্লেসমেন্ট হতেই পারে না। These maximum displacements of the particle are called its amplitude and marked by letter A. So the yellow line really is the amplitude of the particle. A equals to amplitude of the particle. How can you find the value of amplitude? Just take a look when the particle reaches at that point. If you put the values of t here, we already learned that the time period of particle, say capital T, in previous discussion we already learned that capital T is 2 pi by b. I'm marking a point on the graph by an orange point here. When does the particle arrive there? Particle ওইখানে কখন পৌঁছচ্ছে? অরেঞ্জ পয়েন্টটায় কখন রিচ করছে? At what time? At time t by 2. So amplitude reach করছে কখন? Further half, that is t by 4. So let's find the value of x when t equals to t by 4. This will give us the maximum displacement or amplitude. So amplitude equal to, we will say, value of x when time is equal to time period by 4, that is 2 pi by 4b. By putting capital T equal to 2 pi by b, that is pi by 2b, which would be equal to a sine b times pi by 2b equal to a sine pi by 2. I have cancelled b and b. Now sine pi by 2, sine 90 degree 1, so value is a. So now you can say the amplitude equals to a. Look at the position of A in the displacement equation. Just take a look at the displacement equation and try to identify the position where small a is occurring. A is occurring just before the sine function. I mean, you can think that amplitude is the coefficient of the sine function. Amplitude of the SHM will be the coefficient of sine function. So let's take this example. Example 1. Suppose a motion of a SHM is given by x equals to 20 sine 2 pi t centimeters. You can straightforward say its amplitude would be 20 centimeters. Remember, amplitude is a distance, so it will have unit. Here position of particle is given in the unit of centimeter, and what is the coefficient to the sine? That is 20. So we can directly say that is the amplitude. Suppose the particle is moving along y direction and its displacement is given by y equals to 15 sine 400 t meter. From there you can say its amplitude to be 15 meter, and so on. Clear? Next, take this example. Get back to the example that we took earlier. Say displacement of a particle is given by a1 sin bt plus a2 cos bt. We reduced the equation by writing it like x equals to a sin bt plus theta, where a1 was taken to be a cos theta and a2 was taken as a sin theta. We just discussed this, so I'm not going for the derivation. We already derived this earlier in this class. Now, what will be the value of A then? That's the question remains now. What will be the value of this A? This is the amplitude of this combined SHM. We can find this amplitude from there. A1 equal to A cos theta and A2 equals to A sin theta. Say the first equation to be equation number 1, second equation to be equation number 2. Square both sides of the equation and add them. Square the equations and just add them. Let's see what we get. So left hand side becomes a1 square plus a2 square. Right hand side becomes a square cos square theta plus a square sin square theta. So a1 square plus a2 square equals to a square common cos square theta plus sin square theta, which is 1. So a square equals to a1 square plus a2 square, you can say, since cos square theta plus sin square theta would be 1. So a would be equal to root over a1 square plus a2 square, and that's the amplitude of the combined SHM motion. Combined SHM. So what have we learned from this particular example? If x equals to a1 sin bt plus a2 cos bt is a given SHM equation, we can straightforward say its amplitude to be this, root a1 square plus a2 square. a1 and a2 being coefficients of sine and cos in the given displacement equation. Let's take one example to clarify this. Suppose displacement of a particle is given by 4 sin pi t plus 3 cos pi t centimeter. By comparing it with the given form, the orange boxed form, you can say that 4 is a1 and 3 is our a2. So amplitude of this joint SHM, amplitude would be root a1 square plus a2 square, that is root 4 square plus 3 square. By Pythagoras, that's 5. Let's take one more example and then we will move on to another topic. Suppose displacement of a particle is given by 6 sin 20 pi t plus 8 cos 20 pi t meter. Find its amplitude. We already know how to do this. The amplitude would be 10 meter. Exactly. Spot on. Root 6 square plus 8 square, that is 10 meter. Okay, good. So we have learned how to find amplitude of a single sine or cosine displacement function, and also we have learned how to find the amplitude of a joint sine or cosine function. From the given form, we can directly do that. No need to convert it to a single sine function and then find amplitude. No need to do that. That's a shortcut. Or that's the process. You can say whatever. Relation between simple harmonic motion and uniform circular motion. Relation between simple harmonic motion and uniform circular motion. How can we find the relation between SHM and UCM? Let's see. But to learn that, we first have to consider a circle. Let's say the radius of the circle, this capital R, center of the circle is O, that point on the circle is A, and the diametrically opposite point is B. Here O is the radius of the circle. Suppose there is a particle which is moving along this circle. I will always show the particle by the orange dot. Moving along this circle in uniform circular motions. Let a particle is moving along this circle in UCM. That means the particle must possess a constant angular speed, say omega, and a constant linear speed v, which is essentially omega times r. We know that the relation between linear and angular speed. Remember, since it's UCM, uniform circular motion, this implies that v and omega both are constant. The angular speed and linear speed are constant. Let the particle start from A at t equal to 0. Let's say the particle starts from point A at t equal to 0. And say the particle reaches point C at t equal to t. Say C point is located somewhere on this circle, say here, that's point C. So position vector of the particle has changed from OA to OC. The angle so formed by the particle, say theta. So theta can be written as omega times t. Omega angular speed, 1 second particle je angular distance cover করে সেটা omega, তো t second এ যাবে omega into t, ওটা হচ্ছে ওই theta টা। The particle is at c at time t equal to t. Now let's draw a projection, I mean a perpendicular from C onto the diameter AB. I am showing the projection by the yellow line. This is the perpendicular. The yellow line is perpendicular to the pink line, the diameter. Say the foot of the projection be n. Foot of the perpendicular is n. Suppose the distance ON is x. The distance ON is x. We will relate x and theta. We will relate x and theta from the triangle OCN. It's a right angle triangle. We can really do that by using sine or cosine. Look at the triangle OCN. And you can clearly see cos theta equals to ON by OC. but theta is omega t, so cos omega t equals to ON means x, OC is R. So you can write x equals to R cos omega t, really. Does this remind you something? X equals to R cos omega t. It's exactly in the form A sin bt. It's exactly in the form of x equals to A sin bt or A cos bt, whatever you can say. It is representative of the form x equals to A cos bt, where A is R and B is omega. See? Which means it will represent an SHM. We just saw that x equals to A sin bt or A cos bt. These forms represent an SHM. So this motion represents simple harmonic motion. Whose motion? Motion of the point N. I have marked by a white dot here. Motion of the point N. The foot of the perpendicular drawn from the particle onto the diameter. What does this mean? Suppose this is the circle again. When the particle was here, this was the position of the particle P. The diameter point N was also there. When the particle moved from this point P to somewhere else, say here, the diameter has moved here. So particle has moved along the circle a bit. The diameter point N has moved along the diameter a bit. When the particle reaches the top from here to here, see, theta is pi by 2. It has moved by an angle of 90 degree. The foot has moved to the center of the circle. You are getting my point? When the particle has moved from, by an angle theta, pi by 2, the diameter has, the particle, the foot of the perpendicular N has moved from the end to the center. তাহলে ওই পার্টিকেলটা যখন এখানে চলে আসবে, পি পয়েন্টে যখন এরকম জায়গায় চলে আসছে, পুরো একেবারে থিটা ইকুয়ালস টু পাই রেডিয়ান কভার করে, দেখো এন পার্টিকেলটা এখান থেকে এখানে মুভ করে চলে আসছে। এই যে when the particle has moved there, covered a total angle of 3 pi by 2. Again draw perpendicular here. It has moved from this end here. And lastly, as the particle covers a total of 2 pi radian and reaches back to its original position, the foot has also moved back from center to this position. In total, you can say that the particle which was traveling in UCM was moving along this path in UCM, whereas the foot is performing simple harmonic motion. The foot has suffered a to and fro motion along the diameter. So if a particle travels along uniform circular motion, the foot drawn from the particle on a diameter travels in the locus of the foot of the perpendicular is simple harmonic motion. The foot is traveling in simple harmonic motion. We will get back here a bit. See, when we have combined or we have compared UCM and SHM, we see a new form of the displacement of the particle, which is written in the yellow box. The new interpretation is that the displacement equation of an SHM can be written as x equals to r cos omega t, where r is the radius of the circle in which the particle was covering UCM and omega is the angular speed. Now from this discussions you can clearly see r is also the amplitude of the particle. From this discussion you can also see that r, capital R, is the amplitude of the simple harmonic motion of the particle, because the mean position of the particle is that center. On the left hand side it moves to a distance of minus r, that's the radius, On the right, it is moving to a distance of plus r. So the particle about the center is oscillating between the 2 points, minor r to plus r, minus r to plus r, minus r to plus r. So amplitude of the particle is r. So here from the discussion we have learned amplitude of the simple harmonic motion will be equal to radius of the uniform circular motion, that is r, or you can also simplify it as a and r are the same thing. And secondly, angular speed, which is also known as angular frequency, is the omega t. So a particle is in uniform circular motion, its projection on the diameter or foot of the perpendicular on the diameter travels in simple harmonic motion. From this analogy, the displacement equation can be written as a sine omega t. Here we have substituted a by small a by capital A and omega in place of b. Whereas the general form that we wrote was x equals to a sine bt. UCM থেকে SHM ডিরাইভ করে আমরা ফর্মটা পেলাম x equals to a sin omega t, whereas previously আমরা বলছিলাম x equals to small a sin bt. তাহলে আমাদের ইকুয়েশনে এতক্ষণ যা ডিসকাশন করে এসেছি সেখানে স্মল এর জায়গাতে ক্যাপিটাল A and স্মল বির জায়গাতে ক্যাপিটাল ওমেগা সাবস্টিটিউট করে দিতে পারি। করলে তাহলে এখন ইকুয়েশনস গুলো কিরকম দেখতে লাগবে? উই উইল কিপ দেম অ্যাজ এ নোট। এতক্ষণ যা ডিসকাশন করেছি সেগুলো সামারি করে নেব, আবার নতুন কিচ্ছু করব না এখন। তাহলে ডিসপ্লেসমেন্ট ইকুয়েশন x ইকুয়াল টু, এখন লিখবো a sin ওমেগা t or x ইকুয়াল টু a cos ওমেগা t। Velocity equation x equal to a omega cos omega t or x equal to minus a omega sin omega t. And acceleration, oops, I have written x in terms place of v, that would be v's. Acceleration vectors, that would be minus omega square x in both cases. We studied that acceleration equal to minus b square x. Now b is omega, so we are writing a equal to minus omega square x. So from now on we will use the symbol capital A for amplitude and omega as the angular frequency. Instead of small a and small b, we will use the special symbols amplitude capital A and angular speed or angular frequency omega. Now a question. Suppose an SHM is represented by this equation x equals to a sin omega t. Find time when x will become a by 2. After what time x will become a by 2? If the particle starts from t equal to 0 and x equal to 0 position. At time t equal to 0, at x equal to 0 position. It's very easy. Just put x equal to a by 2. So a by 2 will be equal to a sine omega t, or sine omega t equals to half, cancelling a and a. Half is the value of sine 30 degree, that is pi by 6. So omega t will be equals to pi by 6 and t equal to pi by 6 omega. T equals to pi by 6 omega. After this time, displacement of the particle will be half the amplitude. Let's take one more question. Another SHM of a particle is represented by x equals to 20 sine 200 pi t centimeter. Find the time when x equals to 10 root 2 centimeter. The solution goes by exactly similar process. We will put x equal to 10 root 2 in the equation. So 10 root 2 would be 20 sine 200 pi t or sine 200 pi t equals to 10 root 2 by 20 root 2 by 2. 2 can be broken as root 2 into root 2, 1 by root 2. 1 by root 2 means sine pi by 4, that is sine 45 degrees. So 200 pi t equals to pi by 4. T equals to 1 by 4 into 200, that is 1 by 800 second. You can easily convert this to millisecond to get a substantial figure. 1000 by 800 millisecond. 2 5s are 10, 2 4s are 8. 5 by 4 millisecond. Consider one more simple harmonic motion. Displacement is 100 cos 400 pi t meter, centimeter or millimeter, whatever we just say. Say 100 cos 400 pi t millimeter. What will be the amplitude of this SHM? It's 100 millimeter. What will be angular frequency of this SHM? That is omega. You can take a direct look at the general form here. X equal to a sine omega t is now our general form of simple harmonic motion. So multiplied to t would be the omega. So in this question, multiplied to t is 400 pi. So angular frequency would be 400 pi. Unit radian per second, SI unit as it is. Frequency F Frequency is given by omega by 2 pi, that formula. Frequency means how many oscillations it is completing in 1 second. (200) unit would be hertz, and time period lastly. Time period is 1 by frequency, so 1 by 200 second. Converting it to millisecond by multiplying by 1000, so it's 5 millisecond. So from given simple harmonic motion data, you can easily find these 4 quantities at once. Just you have to learn the equation, the displacement equation. Let's get back to the spring mass system. Suppose the spring has a force constant K equals to 200 Newton per meter, and the mass connected to it, M, is given 2 kilograms. In the question, it is given that the mass is displaced from the original position by pulling it, say by pulling it, suppose say 5 centimeters, just say by pulling it 5 centimeters from the mean position. So here 2 questions arises. Number 1, what would be the amplitude? What would be the time period of oscillation? What will be the amplitude and what will be the time period of oscillation? You know, there is a trick. Whenever in this type of question you pull something and release it from there, instantly that position becomes its extremities. Due to conservation of energy, তুমি একটা স্প্রিং তাকে অরিজিনাল পজিশন থেকে 5 সেন্টিমিটার ডিসপ্লেস করে রিলিজ করছো, তো এটা অসিলেট করে যখন টু প্রিভিয়াস পজিশনে যাবে তো ওদিকে আরো -5 সেন্টিমিটার ট্রাভেল করবে, বাট ইট ক্যানট গো বিয়ন্ড দ্যাট। তারপর আবার যখন এদিকে আসবে ইট ক্যান কাম অ্যাট মোস্ট 5 সেন্টিমিটার, সো ইট উইল অসিলেট বিটুইন -5 টু +5, নট মোর দ্যান দ্যাট। তো পেন্ডুলাম হোক বা এই টাইপের যে কোনো ধরনের যে স্ট্রাকচার গুলো, কোনো কিছু ডিসপ্লেস করে যখন আমরা রিলিজ করব, যেখান থেকে রিলিজ করব ওটাই তার এক্সট্রিমিটি, দ্যাট ইজ ওটাই তার অ্যামপ্লিটিউড। দেয়ার ইজ নো ম্যাথ। So amplitude is 5 centimeter. But what about the time period? To find the time period, we will first find the omega. Look at the discussion we made on the springs earlier. The example 4, it's here. We took a spring mass system. We saw that the acceleration is taking the form minus k by m times x, where k by m was constant. We will recall that equation. So for this, equation, for this particular spring mass system, A is, again we will write it minus k by m times x, where k in the question given 200, mass m is given 2, so it's minus 100x. So acceleration vector equals to minus 100x. But see, we have just stated that any simple harmonic motion, now in our location, our notation under the note, I already wrote it, acceleration would be minus omega square x. That's our form. So as per given data, a equal to minus omega square x, but as per our known form, acceleration comes out to be minus omega square x if it's a simple harmonic motion. So by comparing, we can now find omega. We say in general acceleration is equal to minus omega square x. Omega is angular frequency. They have said a equal to minus 100x. So omega square must be 100 by comparing. So omega would be 10. So time period would be 2 pi by omega. 2 pi by 10 second or pi by 5 second. Now let's take a few more examples. Take this question. Suppose displacement of a particle in SHM is given by A0 sine 2 pi f0 t. It is given like so. Find time when its displacement is root 3 a naught by 2. That means x is given. They have asked us to find for a new displacement what is the time that it will take to go there. Given it started from x equal to 0 at t equal to 0. It's stated already. So simply what we do, we just put the value of displacement there. Already করলাম এরকম কয়েকটা, আমাদের ওই একটাই টেকনিক. We won't go anywhere else. There's only one technique. Root 3 a0 by 2, the displacement is a naught sine 2 pi f0 t. Don't get confused by whatever given inside the argument of sine. 2 pi f0 a b c d e f g h doesn't matter. We just need to put x equal to the value of displacement given in the question, like here root 3 a naught by 2, and then we will find t. Other figures will be taken constant. We don't mind the other figures, whatever. So root 3 by 2 means sine 60 degree, that is pi by 3 in radian. Always express the angles in radian, not degree. Degree doesn't work here. So by comparing, you say 2 pi f naught t equal to pi by 3. So t will be 1 by 6 f naught. Okay. So far we have learned what might be the displacement equation of a SHM, sine or cos or the sum. First thing. Second thing, we have learned the coefficient to the sine or cosine, a, capital A or small a, that is the amplitude. and inside the sine function whatever is multiplied to small t is the omega, angular frequency. So here also in this question you can see 2 pi f0 is the angular frequency, that's omega for us. If we have a function like sine something into t, that something is our omega. Suppose SHM of a particle is given by x equals to 3 plus 2 sine 10 pi t plus pi by 6 centimeter. Suppose this is given. Now you can first argue that is it simple harmonic motion? Because there is something added to the positive, 3 plus something is given. Yeah, of course, x equal to 3 plus 2 sine 10 pi t plus pi by c. It's a simple harmonic motion, because if you take the velocity dx dt, you will see the 3 term goes, or acceleration, the 3 term goes. So finally you will get a proportional to minus x thing. But what will be its amplitude? It's an SHM. Okay, it's an SHM, simple harmonic motion, no doubt about that. It contains the term sine function, so it's simple harmonic motion. Whatever be added, nothing. Do not mind them. You do not have to mind whatever is added to this function. But what will be its amplitude? For amplitude, we have to convert it in the form x equals to a sine omega t. Then whatever is multiplied to sine function will be a. Simple. X minus 3 equal to 2 sine 10 pi t plus pi by 6. X minus 3, take it the new variable capital X, 2 sine 10 pi t plus pi by 6. So yes, the amplitude now appears to be 2 centimeter. Just send 3 on the other hand side and take x minus 3. X is our new coordinate. X minus 3 is capital X. I have taken that. That means the equilibrium position of the particle is x equal to 3, not x equal to 0. The mean position is not x equal to 0 for this particle. I will also write that. For mean position, you probably know that x should be 0, but our new variable is capital X, so capital X should be 0. So small x minus 3 equal to 0, so x equals to 3. So mean position is not x equal to 0 as were in the previous functions. So if you plot this graph, t here, say that is x equal to 0, say here we show x equal to 3 position, and the particle oscillates about this position. This is its mean position, that's it, nothing else. This is the new mean position of the particle, not this. ওখানে ওই 3 টার্মটা না থাকলে, 3 অ্যাডেড না থাকলে, তাহলে মিন পজিশন x ইকুয়াল টু 0, মানে হোয়াইট লাইন ধরে যেত। ঠিক আছে? The particle is not oscillating about the white line. The particle is oscillating about this line. So amplitude is 2. From here to here the distance is 2. That distance is 2 centimeter, the amplitude. And from mean position to that distance must be 5 centimeter then. From x equal to 0 the amplitude must be 5. But we do not say amplitude from x equal to 0. We always say amplitude is the distance from mean position. We measure amplitude not from x equal to 0 but from mean position. Its mean position is not x equal to 0. So amplitude is not 5. Amplitude is 2 cm. এই জায়গাটা একটু কনফিউজিং সিনারিও হতে পারে, সো এখানটা কেয়ারফুল থাকবে। মানে মিন x ইকুয়াল টু 0 থেকে ম্যাক্সিমাম ডিসপ্লেসমেন্ট 5, কিন্তু তাতে কি, ওইটা আমাদের মিন পজিশন অ্যামপ্লিটিউডের ডেফিনিশন না তো। অ্যামপ্লিটিউড মিন্স ডিসটেন্স ফ্রম মিন পজিশন, তো মিন পজিশনটাই পাল্টে গেছে। Number 3, what is the epoch That's a relatively new term. Epoch means the phase or the angle traveled by the particle at t equal to 0 at the start. So let's define them. Epoch equals to phase of the particle or the phase angle at t equal to 0. So here the phase angle is 10 pi t plus pi by 6. The total is the phase angle. So 10 pi t plus pi by 6, its value at t equal to 0, which is 10 pi into 0 plus pi by 6, that is pi by 6 radian. It's called the epoch or the initial phase. This means the particle has not started from x equal to 0 exactly, but it has little bit advanced position from x equal to 0. We will discuss it the next day. Today we are not going to discuss that. So we have learned more or less the basics of the displacement, about the displacement of a particle in SHM. Today we will discuss one more topic on SHM, which is the velocity of SHM. Velocity of a particle in simple harmonic motion, or simply velocity of simple harmonic motion. Here we will discuss two cases. Case 1, when displacement of a particle is given by a sine omega t form. Instead of small a and small b, we are now writing the terms capital A and omega. Small a means amplitude, capital A. Small b means angular frequency, that is our omega. So what will be the velocity? You do it by yourself, dx dt, derivative. It will be a omega cos omega t. Case 2, if displacement was a cosine function, a cos omega t, then velocity would be minus a omega sine omega t. Now what is modulus of v then? A omega cos omega t, which is equal to a omega times cos theta means root 1 minus sine square theta. Since sine square plus cos square 1, cos square equal to 1 minus sine square, cos is root 1 minus sine square. Now you see x equals to a sine omega t. From there you can substitute sine omega t means x by a. So sine square omega t must be x square by a square. Simplify, it's a square minus x square under root divided by a square under root, it comes out to be a, which cancels out. So magnitude of velocity can be written as omega root a square minus x square. Since there is a square root, the actual velocity might be positive or negative, both. Since there is a square root, actual velocity might be positive, might be negative. Let's do the same thing with case 2. Here mod v is negative sign goes a omega sine omega t equals to a omega root 1 minus cos square omega t, and again substituting this here, root 1 minus cos omega t means x by a, so cos square omega t means x square by a square. a omega root a square minus x square by a, cancels out again. So mod v equals to omega root x square minus x square. So the vector form might be both positive and negative. What do you see? We took displacement equation of two different forms. Here there was a sinusoidal displacement equation. Here was a cosine form of displacement equation. But velocity and position relation is the same for both. So it doesn't matter whether the wave is moving in sinusoidal or cosine form. The relation between v and x always the same. Omega root a square minus x square. x sin হোক cosine হোক যা হোক তাকে দরকার নেই, ডিসপ্লেসমেন্ট তাহলে x গিভেন থাকলেই v ইকুয়াল টু ওমেগা রুট a স্কয়ার মাইনাস x স্কয়ার, এই ফর্মুলা দিয়ে ফাইন্ড আউট করা যাবে, যেখানে a হচ্ছে অ্যামপ্লিটিউড, ওমেগা অ্যাঙ্গুলার ফ্রিকোয়েন্সি। both are actually the same formula. So let's take a question on this. An SHM is represented by x equal to 20 sine 10t centimeter. Find velocity of the particle at x equal to 10 centimeter. Displacement of a particle is given. We have to find the velocity at a distance of x equal to 10 centimeter, that is half the amplitude. So just compare the equation in the form with the form x equals to a sine omega t. You will instantly get a equals to 20 centimeter and omega equals to 10 radian per second. So velocity at x equals to 10 centimeter will be given by the formula omega root a square minus x square, where omega is 10, a square is 20 square, that is 400, x square is 10 square, that is 100. That's it. So 10 into root 300, that is 10 into 10 root 3, 20 root 3 centimeter per second. Okay, that's the velocity of the particle at x equal to 10 centimeter. Let's consider the next question. In an SHM, velocity of a particle at x equal to x1 is v1, and velocity at x equals to x2 position is v2. It's given. At the position x equal to x1, the velocity is v1, and at the position x equal to x2, velocity is v2. Velocity and displacement both are varying, sinusoidal cosine function might be. The functions are not given, we don't have to know that also. So there might be two questions on this data. Either they may ask you to find omega, or they may ask you to find amplitude. Both can be derived using the same equation, v equal to omega root a square minus x square. Just let's write us down the equation. V equals to plus minus omega root a square minus x square. We know that. 100 root 3. Sorry. Right. 100 times 100, so later it would be 100 root 3. So root 3 meter per second can also be written. Good observation. So velocity equal to plus or minus omega root a square minus x square. That means velocity squared would be omega square into a square minus x square. Now from the first condition, when x equal to x1, velocity is v1. So really v1 square equal to omega square times a square minus x1 square. And from second condition, at position x2 velocity is v2. So v2 square would be omega square times a square minus x2 square. So we have two equations, we have two unknowns, omega and a. By solving this we can easily find them. Let's first find a, amplitude. Let's do that. We are finding amplitude first. For this we will divide the equations by each other, like 1 divided by 2. So v1 square by v2 square would be equal to omega square cancels out, a square minus x1 square by a square minus x2 square. From there you can really find a. I will leave that to you as homework. You can do it by yourself. It's very easy. Just simplification needed. Cross multiplication and simplification. Nothing else. Finding the value of omega. For this purpose, we will modify the equations little bit. Equation number 1 gives us v1 square by omega square equals to a square minus x1 square. And equation 2 gives us v2 square by omega square equals to a square minus x2 square. Very simple, I have just cross multiplied. Now just add them up or subtract, better. Minus, this minus becomes plus. So v1 square by omega square minus v2 square by omega square equals to, look, a square and minus a square will cancel out. So minus x1 square plus x2 square, that is x2 square minus x1 square. So just take 1 by omega square common. I think you know the rest of the deal. From this equation you can really find what is omega. I will also leave these to you for homework. It's just a matter of simplification now. We are taking a very important note here. We will make a list of three quantities: the time, the displacement and velocity. At what time, what is the displacement and what is the velocity? So T stands for time, X stands for displacement, V stands for velocity. We will take these time points: t equal to 0, t equal to capital T by 4, that is time period by 4, 1/4 of time period, half time period T by 2, 3t by 4, quarter time period, and the full time period. What happens at the ends of these time periods? we are going to use the equations x equals to a sine omega t, which is a sine omega means 2 pi by capital T, where capital T is the time period. Using this equation, we will find the values of x, and then we will use the equation v equal to omega root a square minus x square, and consider the positive or negative sign to find the value of v from x. So let's start. First put t equal to 0 in this equation. So you will get x equals to a sine 0 from here. So 0. And what is the velocity of the particle? V equal to omega root a square minus x square. X has value 0. So it's omega a. So it's plus omega a. It's plus omega a. That means at time point 0, I have assumed that the particle is at the mean position. It's traveling towards the right. That's velocity is positive. You may think of a pendulum, tick tock, going from mean position is moving towards the right. That is velocity plus omega a. From this equation, it's evident at x equal to 0. Now, what happens to its displacement at time t by 4? Again, put there t by 4. So x equals to a sine 2 pi capital T by 4 into t. T cancels out, pi by 2. Sine pi by 2 is 90 degrees, so it's a. At quarter time period, the particle is at amplitude, at its extremity, right extremity, you say, plus a. And what is its velocity? From this equation, omega root a square minus x has value a, so a square, there is 0. x equal to a sin 2 pi t by capital T থেকে x find করছি, ওই ভ্যালু ইউজ করে v equal to omega root a square minus x square থেকে v find করছি. Again put x equal to t by 2 here. So a sin 2 pi by capital into small t means t by 2. Sin pi is 0, so the displacement is 0. Now the velocity, it's again omega a, but this time the velocity would be negative. Consider the pendulum at time point 0, the pendulum was at mean position, x equal to 0. It was moving towards right with velocity omega a, so velocity was taken positive. When it moves to right extremity at t by 4 quarter time period, displacement is a, the maximum from mean position, and velocity is 0 because it stops momentarily there. Then again it's coming back towards the mean position. At t by 2 or half time period, it again comes back to mean position, but now it is moving towards left. So velocity is negative. Similarly, you can find easily when it is at 3t by 4, it moves to the left extremity, minus a, by putting it in the function a sin 2 by t by t, velocity would be 0. After a full time period, it comes back to mean position with the same velocity omega a. So you see a cycle, a repetitive cycle of displacement and velocity. It will be so because it's sine function or cosine function, because it's simple harmonic motion. The values of displacement and velocities repeat themselves after certain time period, there is t. So initial velocity is same as the velocity at time period t. Initial displacement is same as here. See, মাঝখানে একটা সময় at t by 2 velocity magnitude same হয়েছিল, কিন্তু direction আবার opposite ছিল. তাহলে velocity value, that is velocity to vector, তো magnitude direction both same repeat হচ্ছে after time period t, where t and omega are related, omega equal to 2 pi by t. So from there we learn one more thing. From the whole data table, you can make this note, of course. magnitude of maximum velocity is omega a. Velocity is never getting more than that. So maximum velocity has a magnitude of omega times a. Now let's check this question. It's given maximum velocity of a particle is 20 meter per second in SHM. Velocity at x equal to 5 centimeter, not 5, sorry, at x equal to 2 centimeter from mean position equal to 8 meter per second. Just make them centimeter, okay? It will be better because there are two units. Maximum velocity of a particle is 20 centimeter per second. Velocity at x equals to 2 semi from mean position is 8 centimeter per second. Find its amplitude and angular speed. Solution goes like this. Maximum velocity is omega times a, which is 20 centimeter in the given data. So omega a equal to 20. That's our first equation. Now velocity at x equal to 2 centimeter can be found by using this relation, putting x equal to 2 there. That velocity is given of magnitude 8. Velocity at 2 centimeter distance, displacement, v equals to omega root a square minus x square. X means 2 square, that is omega root a square minus 4. So this velocity is given as 8. So that is equation number 2. So just divide 1 by 2. So, I will do one more thing. Square both sides of 1 and then divide it by 2. No. Okay. Easy. Go easy. Omega a by omega root a square minus 4. Okay, that's it. We can do it from here. Equal to 20 by 8. So this will cancel out omega. And the right hand side simplifies to 4 5s are 20, 4 2s are 8, 5 by 2. Now square both sides. So it's a square by a square minus 4. It would be 25 by 4. Just do cross multiplication and solve it. So 25a square minus 100 equal to 4a square. 21a square equal to 100. A square equal to 100 by 21. A equal to really 10 by root 21. That's the amplitude. Forming equation 1 and 2 matters. That's physics. The rest is mathematics. Now you can put this value of a back to any equation of 1 and 2 and to get the omega. So like from 1, say suppose I want to put this value back to equation number 1. So omega is 20 by a. Put this value of a here. 20 by 10 into root 21 to root 21. That's omega. I think this should be sufficient for today. You are already drooling. তো আজকে এই পর্যন্ত থাক তাহলে। So we have studied and analyzed displacement and velocity basically, and some other terms like amplitude, like frequency, like time period, etc. They're minor things. Mostly we have already completed our discussion on displacement and velocity of a particle in simple harmonic motion. In the next class we are going to discuss about first the acceleration and different types of simple harmonic motions, like simple harmonic motion of a particle or a floating ball on a water, simple harmonic motion of pendulums, that is called angular simple harmonic motion, and many more spring mass systems. We will need at least 2 more classes to complete this topic, this chapter. The next day we are going to study different types of simple harmonic motion along with acceleration, force, etc. And the last day we will discuss about the energy in the simple harmonic motion, what amount of energy the particle bears, and some other calculations that are required. Okay, so that's for it today. ওটাকে বন্ধ করে দাও, রেকর্ডিংটা স্টপ করে দাও। সায়নী।